For nearly all of human history, if you wanted to build the tallest structure on Earth, you followed a simple rule: make it just a little bit taller than the last record holder. A 5%, maybe 10% increase was enough. But in 2004, a project began in Dubai that shattered that rule entirely. Its goal wasn't just to be the tallest, it was to be so unimaginably tall, to win by such a huge margin, that it would discourage any challenger for generations. This is the story of the Burj Khalifa, and the surprising reasons why, over a decade later, its crown remains untouched. The obsession with height is ancient. For 4,000 years, the Great Pyramid of Giza held the title. Then came cathedrals, and eventually, the Eiffel Tower. But the modern skyscraper race truly began in the late 19th century in Chicago and New York, driven by economics, not royalty or religion. It was about fitting more people and offices into valuable urban land. For most of the 20th century, the battle raged between American cities, with the Empire State Building holding the record for 40 years. Then, in the late 90s, the focus shifted to Asia with the Petronas Towers and later Taipei 101. The bar was raised to just over 500 meters, but Dubai was planning something else entirely. Initially, the plan was for a 550-meter tower, just enough to beat Taipei 101. But as designers dug in, they realized they could go much, much higher. The vision expanded. Dubai, aiming to transform from an oil-based economy to a global tourism and business hub, needed a landmark that would stop the world in its tracks. The result? An astonishing 829-meter tower, 62% taller than its nearest rival. It was a monumental risk. The construction involved 12,000 workers from over 100 countries, 22 million work hours, and a cost of $1.5 billion. But the gamble paid off. The Burj didn't just become a building. It became the engine for Dubai's new downtown, skyrocketing property values and cementing the city's place on the world map. So, what's the secret sauce? Why is this record so durable? The answer lies in revolutionary engineering. The Burj Khalifa's genius is its buttressed core design. Imagine a tripod with 3 wings, stabilized by a massive hexagonal core at its center. This Y-shape, conceived by structural engineer Bill Baker, is incredibly efficient at countering the tremendous wind forces at such heights. Compare this to other super-tall towers that need giant gaps or empty floors to let wind pass through. The Burj's design is inherently stable. Its foundation, with 192 piles driven 50 meters into the ground, is like the roots of a giant tree. It also pioneered construction techniques, like using superpowered concrete pumps. Beyond structure, it's a technological marvel. Its facade is the world's largest LED screen, with 1.2 million lights creating breathtaking displays. Since 2009, many have tried. Of the world's 20 tallest buildings today, 17 were built after the Burj, but none have come close to its height. 2 serious contenders emerged: the Jeddah Tower in Saudi Arabia, aiming for over 1 kilometer, and Dubai's own Creek Tower. Both are stalled. Jeddah due to funding and political shifts. Creek Tower delayed post-Expo. Then we enter the realm of concept designs. Kuwait's proposed Mubarak Al Kabir Tower, or Tokyo's mind-bending 1.7-kilometer Sky Mile Tower for 500,000 residents. These are visionary, but firmly on the drawing board. The truth is, building taller than the Burj isn't just an engineering puzzle. The ultimate limits aren't just about physics. Engineer Bill Baker believes, theoretically, we could build a structure several kilometers tall, but practically, we face 3 walls. First, economics. These projects cost tens of billions. The Burj succeeded because it catalyzed a whole new economic zone. That's a rare and huge gamble. Second, government will. Even China, a skyscraper hub, now bans buildings over 500 meters, calling them wasteful vanity projects. And third, human factors. In a building over 1.5 kilometers tall, elevator rides would require pressure adaptation, like climbing a mountain instantly. Upper floors would need to be sealed environments. Until we find revolutionary new materials, a compelling economic model, and solve the human altitude problem, the practical skyscraper height may have found its current ceiling. The Burj Khalifa stands not just as a testament to what we can build, but as a symbol of a specific moment, when ambition, oil, wealth, economic vision, and groundbreaking engineering converged. It may be decades before we see that perfect storm again. For now, it reigns supreme. What do you think? Will we see a kilometer-tall building in our lifetime? Let me know in the comments. If you enjoyed this deep dive, check out our video on the rise and fall of supersonic passenger travel. Thanks for watching, and I'll see you in the next one.